Thanks for joining our session. It's been an amazing week this week here in San Francisco. So before we'll start the session, I'm happy to tell you a little bit about DoiT International. My name is Ifat Yanai, and I'm a partner manager at Google Cloud, based in Tel Aviv. Part of my role is to work with partners like DoiT International and help them to succeed and bring the best out of Google Cloud to our shared customers. DoiT International was founded in 2010 by a small number of software engineers that actually understood in early stages that App Engine, which is the first Google Cloud product, can bring lots of value to startups and help startups to focus on their main business, on sites, application, rather than invest in maintenance and infrastructure. And since then, they did lots of implementation with many customers using App Engine and, of course, some other products and leveraged the Google Cloud solutions. DoiT International became a global partner of Google Cloud. They are very active in Israel, USA, and also Europe. And they are doing lots of projects and implementation, large-scale customers, and bringing the best, as I said, of Google Cloud to our customers. In addition to great professional services and support to our customers, DoiT are very active and contribute to the open source community by developing lots of open source tools. Just go quickly on some of them to get you a sense of examples. One of them is Shamash, which is an auto-scaling tool for Manage Hadoop and Spark, Google Manage Hadoop and Spark. Another good example is Zaraya, which is a scheduler that scheduler for a compute engine, which can give customers actually to use this product, and it's an open source, of course, and sometimes reduce their infrastructure cost up to 60% of non-production environment. And the most famous one is Reoptimize. Reoptimize is an open source tool, open source platform for cost optimization. It is also available in Google Marketplace, and it helps customers to get a better view of their workloads and usage of their cloud and do optimization of their costs. And there are so many other tools, and we will cover some of them during the session. And I'm happy now to invite to stage Vadim Solovey, who is the founder of DoiT and the CTO. Welcome, Vadim.
Thanks, Ifat, for this great introduction. I guess I couldn't do better myself. So hello, everyone. We're gonna have, let me quickly catch up here on things. Okay. So during our session today, I'm going to tell you a customer story, some mutual project that we had together with a company called Jellybutton. So for these people who do not know, Jellybutton is a gaming company. They produce mobile games. And one of the most famous games is called Pirate Kings. So Pirate Kings have over 100 million active users worldwide, people who play the game on their iOS or Android device. And today we are going to talk about how Jellybutton have replaced their event analytics pipeline based on the solution that I'm going to present you right now. And it's not a big secret that most people, when they want to deploy some sort of the event analytics pipeline or platform, they start with the off-the-shelf products, right? And there are so many available solutions on the market, products such as Mixpanel or Segment or even Google Analytics or Kissmetrics and so many others. And don't get me wrong, all of those solutions are excellent, and they definitely have their own market. However, this session will focus on how you can build your own event analytics platform. And why would you do that, you may ask? Well, usually it's because the off-the-shelf platforms, they won't be as flexible as you'd like, or sometimes they have a very high cost. And the cost is usually some sort of the per event price that you pay. Usually it's gradually decreasing over volume, like as you have more events, you will probably pay a little bit less. However, at a certain scale, the price can go up as high as tens of thousands of dollars per month. And in that case, in the Jelly Button case specifically, they were spending between $45,000 to $65,000 per month on their off-the-shelf event analytics platform, depending on how popular their game was on a certain month. And finally, another problem that usually exists with the off-the-shelf solution is they don't allow you to easily own your own data. Meaning that making it accessible and available to your other systems and services. And for example, you can't use your own BI tool of choice, and you will have to use the charting and reporting engine that is a part of the off-the-shelf tool. And you can't give your data analysts an ability to query your data using standard SQL. And usually you will need to use some sort of a proprietary language. And there are many more examples why those systems can be a little bit limiting sometimes. So for a couple of years, Jelly Button were using the off-the-shelf analytics platform to the point that it wasn't longer financially feasible, and the flexibility wasn't good enough. So Jelly Button has decided to build a new system. And the design principle of that new system would be it has to be flexible in a way that it will allow them to analyze their data in any way they would like using standard SQL or any BI tool of choice. It should be cheap to build, operate, and maintain over time. And it should have much better economy of scale comparing to the off-the-shelf solution that they had. And finally, it has to be global. Since there are players anywhere in the world, they wanted the events to be sent with the lowest latency possible. And so based on all of those design goals, we came up with the following high-level architecture of their own event analytics pipeline. And let me walk you through this architecture at the high level before we are going to deep dive into the specifics of each and every part. So first, we have the ingestion part. This is where we get the events from mobile devices and process them. In general, there are two distinct types of events. One type are the events being sent from the game itself, from the mobile device. For example, users logging in, going from one level to the other, or accumulating stars, or doing in-app purchases. Another kind of the event are the events generated by the gaming backend. These are more system-level events, and usually they are good indicators of the overall platform health. The next big part is the event processing. This is where we validate the events, parse them, store them for future analysis. This is also where we calculate certain metrics, such as leaderboards, or enriching the events with the other data, such as geolocation of users, for example. And finally, the last piece is where we generate the reports and allow the data scientists to analyze the events. So now let's take a closer look at the event ingestion part. So to ingest the events, we need to have some sort of the RESTful API with which our mobile SDK can communicate and send the events, right? And we have written an initial version of our API in Node.js, and we have decided to run it on top of the Kubernetes, or specifically GKE, which is a Google managed Kubernetes. So you might ask, why have we choose GKE to run our API? Well, we have considered other options, such as compute engine, for example, but we wanted something more managed, so we wouldn't be bothered with things like autoscaling or monitoring or doing version upgrades of our software. We have also considered App Engine, which is a Google platform as a service, which we have used many, many times in the past for our other solutions. However, App Engine as of today, while it has some really beautiful tools for seamless deployments and autoscaling, it is a little bit limited to only one geographical region, and we wanted to have multiple endpoints in many places and in multiple geographies. So finally, the reason that we have used a GKE is because GKE gave us exactly the features we needed. Fully managed infrastructure on one hand, but with an ability to run multiple clusters in different regions while being able to deploy a single version of our API. And we are using features such as horizontal pod autoscaling to control the number of API pods running according to the amounts of the event per second that we are getting. And also the GKE node autoscaler, which is automatically increases or decreases the number of nodes as in accordance with the amount of the pods that we are running at the same time. And on top of that, we are also using a really nice feature called cluster federation. So cluster federation is essentially a Kubernetes feature which gives you an ability to build, I would like to say, like a supercluster. So you can have multiple clusters. Every cluster can be in a different region, or even a different cloud provider or on premises. But you can still manage all of those clusters from a single control plane. And it's a very powerful feature, as you can imagine, because I can have my API running just anywhere in the world, but still controlling everything from a single place. And finally, the other very important piece here is the Google HTTPS load balancer. So we are using something that's called global IP, which allows us to have a single Anycast IP address for our API. And the request that is being sent from the mobile device is resolving that IP address to the nearest location that Google has in the same region. And that's done automatically for you. So initially, we had a couple of clusters, one in North America and the other one in Western Europe. But eventually, we have added more clusters in the other places as well, just to cover them. So to summarize that point, we have a single IP. All of the events are being sent to that single IP. The IP is being resolved to a local cluster in the region that is geographically close to the end user player, and then the API processes the event and pushes it forward. So just to give you a good example of how having a local cluster in certain geographies improves the overall latency, let's first take a look on the median latency for North America or Western Europe. So it's 89 milliseconds and 54 milliseconds for Europe. However, as you can see, for players in Asia Pacific, without the local cluster there, the latency was on a scale of 250 milliseconds, almost 5 times longer than for players in geographies where we have local clusters. But thanks to the Kubernetes Federation, it was very easy for us to add another cluster in Asia Pacific, and that immediately brought down the latency to just 61 milliseconds, which is almost 75% improvement. And we didn't have to change anything to support this additional cluster. The IP of our API stayed exactly the same thanks to the global IP feature. We didn't have to update the mobile application just because we added a new cluster. And once we had the cluster up and running under the federation, The Kubernetes pushed the latest version of our API to that cluster, and the Google HTTP load balancer started to route new requests coming from Asia Pacific to that new local cluster. And as there will be more players in other regions, it will be as seamless for us to add additional clusters in the same way over time. Another piece of technology we are using here is a Google Cloud Endpoints. We obviously have to protect the API from unauthorized use, and we are using Cloud Endpoints to provide additional features that we just didn't want to develop ourselves, and rather prefer to rely on Google. So we are using Cloud Endpoints to provide us with authentication, rate control, and monitoring. And let me put a little bit more context here. So, of course, authentication is important because we don't want unauthorized devices or bots to send us ingenuine data. And by using Cloud Endpoints, we ensure that only devices providing the correct authentication token can send us the event data. Rate control is another very important thing, because even while unauthenticated bots, they cannot send the data because they do not have the token, they can still make attempts to send the data, and if there is enough of them, it will be some sort of the denial of service attack, right? Causing us to spend extra money on more resources such as Kubernetes nodes or network egress traffic. And finally, Cloud Endpoints provide many additional features such as monitoring our API. We can version the API, and maybe most importantly, it can automatically generate the mobile SDK for iOS and Android. So once we introduce a change to our API, we can automatically generate the SDK and use that SDK in our next version of the game. Now that we are almost done with the API part itself, the final but very important part is the Google PubSub. So in general, we are using PubSub to temporarily store our event data that we are getting from the devices. PubSub is a managed message bus, which essentially means that we can create a topic. It's a little bit similar to, I would say, water pipe. And then to send the data from one side of that pipe to the other side. And in our case, we are using PubSub because it's a good practice to build systems in a way where the communication between different parts of our system will be asynchronous. In that way, we can scale the different parts separately, one from the other, and also, if some part is under a load or a pressure, or even down, we are not losing any data. So we are getting the event from the API running on Kubernetes, and we are putting that event into the PubSub. So let's see what happens next. So after the ingestion part is done, we are getting into the event processing. So what do I mean by event processing? Event processing, it's actually many things that we need or have to do to allow effective analysis of the data. So first, we need to parse the events, and then we need to make sure they are complete and valid. Usually, after that, we will want to enrich our data. For example, one of the most popular enrichments are geolocation based on the IP address of the request. We would like to know the city, country, perhaps some other data of the player. And after enrichment, we are grouping and aggregating the data because sometimes we would like to store different events in different tables in our database. I will get to that a little bit later. And we also want to calculate some metrics on the fly. So for example, think of the leaderboard. So we want to display a leaderboard on our website to see how many stars every player has. So one way of doing that would be to store everything in some database and then make some queries over that data and, let's say, refresh them every minute or something. What we are doing here, we are actually calculating the leaderboard on the fly at the time that we process the events. And that's pretty cool, right? So for event processing, we are using Apache Beam. It's an open source project originated from Google several years ago. And now it's a part of Apache Foundation. Well, specifically in our case, we are using Google Cloud Dataflow, which is a managed version of the Apache Beam. So we wouldn't need to worry about deploying our own servers or scaling them or monitoring them according to the volume of the data that we are receiving. And Google Cloud Dataflow is basically a cloud-based version of the ETL, of the extract transform load paradigm. And with Dataflow, we can read the data from a certain source, parse the data, transform it, aggregate it, group it, and finally send it to another destination. And you can write the Google Dataflow pipelines or jobs in Java or Python. And it has a long list of supported connectors to various Google Cloud products, such as PubSub or BigQuery or Bigtable or Spanner or Cloud SQL and so many others. And if you'd like, you can even use Apache Beam and run your jobs on external data processing engines such as Spark or Flink, which means it gives you the freedom of running your workloads just anywhere without any kind of a vendor lock-in. And this was something that was very important for us because we wanted to give that freedom and to be able to basically run it everywhere if so we choose. So in our case, we are reading the data from the Google PubSub. We are parsing the data. We are doing the aggregation and groupings, and finally sending the data to the Google BigQuery and Bigtable for further analysis. So the code that you are seeing right now is some kind of a pseudocode, because the actual code, while it looks like very similar, it's a little bit more verbose because Java is a pretty verbose language. So I just couldn't fit it to put it on the slide, but you get the idea. And the Apache Beam SDK is very powerful in a sense that you can write a very complicated code. You can have a very complicated pipeline, but your code is very short. And once you deploy your code, the Google Dataflow will automatically build a graph, which you can see on the right side of the slide. So that graph is being automatically generated from your code. You will see that on the Google Cloud console along some monitoring information on how your pipeline is performing, meaning, for example, how many events you are processing, what is the delay of the event, or in other words, how much time does it take to process a single event from a second it's being read from the Google PubSub until to the point that it's being pushed to the Google BigQuery. And then you can monitor those metrics and build some sort of alerts so you can be notified if your pipeline is performing worse than you would expect. And here's the actual graph, by the way, for the demo that we will be showing shortly. So in that graph, you can see that we are reading a people data. Actually, it's an information about our users, and the event data, which are the actual events, like login or moving from one level to the other. And then we are doing the parsing and aggregations, and essentially, finally, we are pushing the data to several destinations. In our case, it's a BigQuery and Bigtable, and I will get to that in, I think, just 1 minute. And since we are using streaming pipelines with Apache Beam, the time window notion is extremely important here. If you are constantly reading the data from some streaming source, such as Google PubSub, for example, and you want to build aggregations on the fly, time windows are essential to be able to do that. So Google Dataflow will automatically assign every event to a correct time window based on the semantic event time, which means the true time when the event actually happened, as opposed to the time that event was received by the Dataflow. Now, with every part is in the correct time window, it is very simple to count, for example, to count the amount of stars each player has to calculate the leaderboard and to update that in real time. And there are many supported window types in Google Dataflow. For example, fixed windows, sliding windows, session windows, or even custom windows, if none of the standard window types doesn't work for you. And windows are also really helpful for taking care of the late events. For example, you can imagine that you are playing the game, but you are in the elevator, or you are in the place where you have a limited network coverage. And in that case, even if your mobile device generates the events, those events are not being sent because you don't have the network. And sometimes it can take a lot of time to actually send those events. It can be minutes, it can be even hours sometimes, if you're taking flight, for example. And one of the greatest things with the Google Dataflow or Apache Beam in that sense is that have the notion of the late events. So while the event can really arrive late by any amount of time, it can still be assigned to the correct window, to the correct time window, so we can correctly recalculate our leaderboards at every given time. And there are many innovations available with Apache Beam 2.x. The latest version is 2.5. And those features, for example, are dynamic destinations. They can help you to send your data to various tables based on the arbitrary data that you are receiving. Or, for example, automatic schema detections, making your life so much easier by not having to hard code your schemas into the code, into the pipeline code that you are producing. And the other really important part here is the data mutability. So the data mutability, as it sounds, it means that some data can change over time. And this may be a little bit difficult with analytical databases such as Google BigQuery, which are append-only by their nature. But what if you have a table of the players and you want to update the player information, for example, on the fly? Well, you may want to update each player's with its current status of the amount of stars that they have or their cash balance. And this is why we have opted to use both Google BigQuery for immutable data, data that doesn't change, such as events, with Bigtable for the mutable data, such as player table. And using Google Cloud Dataflow, we are sending those events directly to the BigQuery, making it available for later analysis by data scientists and our BI tools. And for those people who doesn't know, Bigtable is a NoSQL database powering some really popular applications such as Gmail or AdWords here at Google. And it's ideal for storing sparse information, such as in our example, people's profiles. And it can support millions of updates every second. Bigtable is managed, which means, once again, we don't need to be bothered with the management by ourselves. And now that we are done with the event processing, let's talk a little bit about the event analytics. So for event analytics, as you can imagine, we are using Google BigQuery. So this is a high level of the BigQuery architecture. One of the greatest things about the BigQuery is that it has storage and compute scaled independently on demand. It helps us to analyze billions of daily events using standard SQL at a great speed. Most of our queries are running only a few seconds, despite the fact that they scan terabytes of the data. And since last year, Google BigQuery allows you not only to query native tables, but also federated tables. And federated tables, it means that they can reside on other storage systems, such as Bigtable, for example. And since Bigtable itself is a NoSQL database, it means you cannot run complex queries on it, right? However, with Google BigQuery and federated tables, you can have the power of both Bigtable and BigQuery by being able to run really complicated SQL queries over NoSQL data. And if you can still remember the beginning of my talk, I barely can myself. You may recall that we wanted the event analytics platform to be very cost-effective. And I also said that the off-the-shelf solution that Jellybutton were using has a significant cost of the tens of thousands of dollars every month. So let's take a short look on how much does it cost us today to run the system that I have just presented. So we are using Reoptimize.io for Google Cloud Analytics. It's available from DoiT International for free. It's a pretty sophisticated tool that have some cost analytics and cost optimization platform. And what you can see here on the slide is one of the cost control dashboards. And so you can see how much we are spending on Google Cloud every month and some breakdown by specific product over time. So in July 2017, when we launched the new system, we were processing about 1.3 billion of daily events. And the overall cost of the Google Cloud for us was on the scale of $1,500 per month. That's all. In January 2018, we were ingesting and processing 3.3 billion events. It's about 3 times more. And our cost was just about $2,000 per month. And finally, during May 2018, just a few months ago, we were already processing 6 billion of daily events, and still our cost is a little bit less than, well, actually a little bit more than $3,000, right? So if you compare that to the $45,000 to $65,000 that we were paying every month before that, that's a pretty significant cost saving, right? You can clap. Thank you, guys. So it took us about 5 weeks of 3 people to build the new system. We have spent about 2 weeks exploring different architectures and prototyping before we could settle on the current state of affairs. Then we took another week to make our code production ready, another week of testing everything in parallel to running the previous system. And finally, over the course of the 5th week, we have gradually moved all of our event analytics traffic to the new system. And right now, I would like to call Yoram, a customer reliability engineer at DoiT International, for the demo.
Okay. Well, thank you, Vadim. Hi, everybody. So we are all familiar with the common flow in which data is coming to PubSub, and from there we take it using Dataflow, doing whatever we want to do with it, and putting it into BigQuery. Since this is the obvious flow, today I'm going to show a little bit about what we are doing with Bigtable and why is it more dynamic and more interesting. So as Vadim said, last year Google announced the federated queries, which allows you to run SQL queries on unstructured data that resides on Bigtable. This allows us to run the same SQL queries on virtual tables on BigQuery that actually belongs to Bigtable. So what we got was 2 requests in the latest version. The first one was to create a dynamic leaderboard for bigger amount of users, something that will not be calculated in Dataflow, but will be taken outside. And the second thing was to be able to remove a user from the system according to the GDPR compliance, the GDPR guidelines. To solve this, we decided to actually put Bigtable into the flow and to split the data according to the need. So we have three types of data. We have the users, which contains the PII. We have the events, which doesn't contain any PII. And the leaderboard, again, doesn't contain any PII. So I want to, this is a part, very small part of the pipeline in Dataflow. I just want you to feel a little bit about what we are doing. We actually have two main flows. We have the one on the left that actually takes data from people, messages that are coming to the people topic on PubSub. It's doing all kind of fancy enrichments. It depends, again, on the game and the requirements. And from there, directly to Bigtable. Now, I want to, let's see a little bit about what we have on Bigtable. So actually on Bigtable, we have two tables. We have the leaderboards and we have the people. Now, if I want to see one of the users, for example, on Bigtable, then I will probably do something like this, and I will get all the history of the user. To the people who don't know, Bigtable actually gives us kind of three-dimensional table. So we have not only the columns and the family names, we also have the time period, a time series of data per each row. But this is not something which is that easy to utilize. So what we did was actually to define the same table using this JSON, to take this JSON and to put it into Bigtable and define the federated external table, the BigQuery table. Sorry, the big table on BigQuery. I have too many bigs and too many tables. My apologies. Sorry. You have to do something about it. So actually, this is the schema of the people table that reside on Bigtable as it represents on BigQuery. Now, from here, if I want to do the same query on the same user, it's relatively easy. And of course, I can see in one line who is the user, what is his age, gender. Again, I defined over here that I want to see only the latest version of each of the columns. Since it's a sparse data, I will get only the relevant data that exists, the latest version over here. Okay. So I want to go back to the second flow, and now the second flow is actually the more interesting one the way I see it, because the second flow takes all the messages that are event related. So it listens to a different topic on PubSub. It takes all the data, all the messages that arrive, and it will do four things with these messages. The first one, store the raw message into BigQuery. And I didn't make a mistake over here, directly to BigQuery. This is actually the single source of truth. The customer can do whatever analytics on the BigQuery using the BigQuery engine. It will run fast, and it will have all the advantages of BigQuery. The second part of the flow will take the event, the same event. Now we will do some kind, again, of any fancy enrichment, and it will update or actually insert new records into two tables. The first one is to the people table. This way, I don't have to calculate outside of Bigtable the status of each user. Once I entered new row or new value for each of these cached stars and cached, the user will automatically have only the latest version that we entered. The second thing is the leaderboard. Now, when I'm doing this, I actually don't need Bigtable to handle all the windowing and splitting and keeping the let arrivals. Not only that, when I'm doing windowing on Dataflow, that I need to define windows, time periods, early firing. Over here, the data is up to date all the time. Again, we are utilizing the very fast response, the millisecond or sub-millisecond response of Bigtable. So let's look a bit into the tables. So what we did was to take the leaderboard. No, I want to start first of all with the more trivial one, which is the immutable events. Again, this is a very standard BigQuery table, native BigQuery table. I'm sure that you're all familiar with. So I will continue to the next one, which is the leaderboard. This is the one that is more interesting. This is a table that exists physically on Bigtable, but we represented it using this JSON. This is very small JSON of, I want to know only the star balance and the cache balance per user. The key that we used over here was actually the date and the user ID. Now, if I want to query for a specific date, I want to see, let's say I want to say, who are the 5 leaders for the, it's not for the 24th, because I just changed the query today to the 25th. So, as you can see, I have the key. From the key, I got the user ID, and I know exactly how much star balance and cache balance. In this case, I ordered it according to the star balance, because usually this is what we care. Now, if somebody from marketing, for example, or from sales, want to better understand who are the best spenders or leaders for a period of time, I can always go and also do the row between and then give a date range or a key range. And according to this key range, get all the relevant data that reside inside this range. In this case, I did from the 22nd till today, and I got a different list of people. This time, they are sorted by the cache balance. Now again, think about the fact that all this data actually reside in Bigtable. This is something that was not possible using CBT or any other common tools working with Bigtable. But once we are working with BigQuery and federated tables, I can do this without any problem. Now, the last thing that we still have is how we remove the user. So again, doing it with BigQuery was a bit more complicated. Here, if I have this user, all I have to do is delete row, and that's it. Hopefully, the gods of demo will not do anything. And yes, he's out. One last thing before I finish. Vadim spoke about part of the flow that we did. This is today, it's the Banias, which is one of the open source that we are speaking about, that we presented earlier. So you can play with it and get 80 to 90% of the flow already. That's it. Thank you.
Thanks, Yoram. So just one thing before we end the session today. So if you are like Jellybutton and you are looking to build your own event analytics pipeline based on the principles that we explained during that session, we have some great news. After implementing that analytics pipeline solution for many other customers in the last year, we have decided to open source that. So you have the whole solution and the whole blueprint publicly available on the GitHub. So it's kind of like opinionated based on our experience as best practices, event analytics pipeline supporting elastic schemas, and you can get going just in a couple of hours. So just clone the repository and of course, fill the issue if you need some help. And, well, some references. You will get them, I guess, when you access that presentation on the Google website. But there are some useful resources that we thought it would be great sharing them with you. Ifat?
So thank you very much, Vadim and Yoram, for a great presentation, and I hope you all enjoy it. And one last thing I wanted to say about DoiT, I don't know if you're all aware, but during this week here in San Francisco, we had a partner summit, and DoiT won third time in a row in the global award for its sales and engineering excellence. So I think they deserve applause for that as well.